Ladies and gentlemen, please welcome the president of ABB Americas, Greg Scheil.
Officially, good afternoon, ladies and gentlemen, and welcome to our Luncheon panel, The Future of Industry. I'll just say a couple words before it. I'll turn it over to our esteemed panel here. First, as we do with all of our work, we start with safety, and I think you all know the numbers if you were there this morning, but if you were not there, take a picture of this. This is in case you need emergency help with the house phone or the outside line. The house phones are a little hard to find, so your smartphone's usually right in your hand, so you probably want to use that one. Hopefully not needed, but in the case it is, certainly have these numbers handy. In addition, if we do need to exit, you can see the exits where we're sitting now in the grand ballroom. Find the exits either behind you or behind us for the way out. Okay, let me turn it over to the panel. First, I'd like to introduce our moderator. Morten Wierod has been announced back in December that he is joining the executive committee as of April 1st, which is coming fast, Morten. So he certainly has been a colleague of ours for many years, in fact 21 years at ABB, has run a variety of the businesses from a global dimension, has lived in Asia, Europe, originally Norwegian, certainly, and we're really proud to have Morten not only joining the executive committee, but starting April 1st running our motion division, which motors and drives, a world leader in both categories. Morten, you will be the moderator for this session, so now I'll turn it over to you for your panel.
Yeah. Thanks a lot, Greg. And it's great to have our 4 panelists with us here today, also up on stage. So thank you for joining. We're going to discuss really around the topic about transformation of the industry and what we're going through, especially with a focus on digitalization and what kind of opportunities, but also some of the challenges that this bring us. So let's go straight to it and let's introduce the panelists we have here. We got Michael Wiebe, from the CEO of Krones. We have also Mortimer from Richard from BP, and have VP of projects. Guido, our CDO in ABB, and also Peter Terwiesch on my left here as head of our industrial automation business. But so let's first just give a very brief introduction, and Michael, I'll start with you. If you could introduce both yourself, but also what you think about the topic we have on the agenda today.
Okay, thank you, Morten. Good afternoon, I'm Michael Wiebe. I'm the Chief Operating Officer for Krones in North America, and that includes Central America and the Caribbean, a pretty nice region. I joined Krones in Canada in 2002, and I currently work in the North American headquarters in the Milwaukee area. My education is mechanical engineering, plus I have an MBA. Und ich kann auch Deutsch sprechen, ich weiß, es gibt sehr viele Deutsche hier. Plus, I still farm in Saskatchewan with my brother, so I'm an ex-farm boy. And we contribute to food and beverage. I'm in the food and beverage industry, of course, but we contribute that way with wheat, barley, canola, peas, and lentils. And farmers love to talk about the weather, so I thought we'd talk a little bit about the weather. Some people say it's a little bit cool here, but the farm is 500 miles north of Billings, Montana, so it's way up there. And this is a heat wave. That's how we see it. This isn't cold. But seriously, Krones is a global firm with group headquarters being in Germany. We have 16,000 employees and 4 billion euro of revenue. So pretty big, but not as big as ABB, probably an order of magnitude bigger. Krones offers complete lines for the packaging industry and food production. And that goes from processing, filling, packaging, and warehouse automation. Every day, millions of bottles go through Krones lines, and cans too. And nowadays, a decent speed line actually produces 1 million bottles in a couple shifts. So it's a lot of millions per day. Operations in North America include customer service and field service and everything in between. That's things like engineering, supply chain, manufacturing, training, and continuous improvement. Krones has 5 locations in North America. In the past few years, we've acquired 7 firms to help us strengthen the house of Krones. On the front end, processing, upstream of packaging, and downstream with the warehouse automation, and also in the digitalization landscape for the roof of the house of Krones to bring everything together. So we're even closer to our North American customers with these acquisitions. So thanks to ABB, a great partner of Krones, for having me here. Our machines use many B&R components. And a special thanks to Jerry Golden, he's probably out there somewhere. He's our key account executive for ABB and B&R in North America, and he does a great job for us. So lastly, the topic, digitalization and future of industry. I think it's very relevant for all of us here. We're all trying to figure that thing out and leverage it to benefit our operations, make us more efficient, and solve some of our pain points. So I'm really happy to be here, and I'm looking forward to the discussion. Thanks.
Thanks, Michael. I think it's very impressive if you see any of the bottling machines or Krones, or Krones as we would say here in the US, and it's amazing to see also, as I say, the efficiency and in this kind of line setup. So great to have you here. Thanks, Michael.
Thank you.
So Richard, Head of Global Projects.
Yeah, so I get my job title right. So I'm Head of Engineering for projects within the upstream of BP. So thank you, Morgan, and thank you, and Peter to some extent, for inviting me to participate in what I find a remarkable exhibition of ABB's product lines and innovation. So myself, my name's Richard Mortimer. I run the engineering side of all oil and gas projects for major gas across the globe with BP. I'm based in Houston. Sorry, I'm based in London, but I spend a lot of time in Houston. I'm also the executive sponsor for BP with ABB, and something we'll come on to later. I'm the chairman of the standards committee of something called IOGP, which is the main cross industry body for the operators of the oil and gas industry. For BP, clearly, there's a lot of challenges, like all companies. It's a very fast-moving world. The key thing for us at the moment is addressing what we call the dual challenge, which is increasing the energy supply in line with global demand, which is due to increase pretty much whoever you look at. There are differences in views on how the fuel mix will go, but it's pretty much the consensus that between now and 2040, the overall energy consumption in the world will increase by 30%. So there's a need to meet that demand and a business opportunity to meet that demand, but at the same time we need to address the issue of greenhouse gas, and we need to keep the greenhouse gas emissions flat and potentially reduce those, something called the dual channel. And to address that, a huge amount of effort going into all sorts of technology things, which we'll come to later on. And the second thing is, like all of us, many of the people in this room, addressing the opportunities, but also the challenges of digital and digitalization. Again, a big issue and a big deal for BP, and all sorts of areas where BP are participating and partnering with ABB to move that forward. And finally, something we'll touch on a little later is the whole point about with the oil price, and people are very familiar with this in Houston, going through the cycles of the oil price, the crash we had since 2014 in the oil price, and need to get our oil and gas, the business is competitive and stable for that longer for lower concept of oil prices in the 50 to 60 barrel. Again, huge application of technology, huge involvement of companies like BP to partner with us to make that successful.
Thanks a lot, Richard. And I think it's great to have BP here, and I think the ones who know even more about BP and what you can how ABB as LBB has worked well together with BP is Peter in your IA role. So maybe, again, introduce yourself, but also give your perspective of today's topic.
Yeah, thanks, Morten. My name is Peter Terwiesch. I lead ABB's industrial automation business, which really serves the process and hybrid industries. And in what we do, we together with our customers, we write the future of safe and smart operations. So what we mean by that is, if in any of the conversations we've also had here now, basically we always get back to our customers being exposed to the challenges and opportunities of the energy revolution and the fourth industrial revolution, and how to basically with automation at the core of that, and automation in the wider sense, including digitalization also, how do we really do we bring down during the project phase the cost, schedule, and risk side of capital projects and make them more digestible? And then later on during the operations phase, what can we do to continuously increase the safety, productivity, and energy efficiency performance? And exactly those are the sort of topics we're discussing closely with BP on a number of assets and projects, but also with many of you who are here. And last not least, I should include in that also, we're in a proud position of actually building on the technologies from the other parts of ABB that are not part of industrial automation. So Morten, big thanks for you on the motors and drive side. Really a leading portfolio that we integrate in the solutions that we build, and the same thing for electrification, for the power grid colleagues also. So we integrate solutions from the digital and the physical ingredients, combining that with domain knowledge and then the application and service capability. That's what we do for you. And look, last comment from my side for this introduction. I find it really exciting to be in this fourth industrial revolution. I think there couldn't be anything more interesting, neither as an engineer nor as a manager, than shaping together with our customers what this actually will be and how this will serve you in the best possible way.
Thanks, Peter. No, and I think we, as you said, we are working very well together, and a lot of the core of ABB from the historical, but we needed some, let's say, a breath of fresh air into the team when it talked about the digital transformation of ABB as well. And therefore Guido came on board, and he has been doing a great job since. So please also present yourself for the rest of the audience here, for those who doesn't know you already.
All right, thank you, Morten. And thank you for calling me a breath of fresh air. I've been called worse, so that's actually a very good comment. Thank you. So in some ways, I feel like I've got the best job at ABB. A leader in automation, a company that's involved in so many different industries. And if you think about the waves of digital adoption, Uli shared this S-curve this morning, for those of you that saw that. I come from a lot of experience in the IT sector, and the IT sector digitized a lot of its operations in the 1990s. However, if you look at the rest of the economy, whether it's manufacturing, energy, oil and gas, many other industries, that S-curve, that inflection point of the impact of digital is happening now. And the reason why I think it's happening now in some sense is that back in the 90s, the main driver of e-commerce and the internet and all the things we saw then was really driven by just two technologies. The internet, which provided connectivity, and the web browser, which democratized access to data. But today, if you look at the technology innovations that are being driven, everything from AI and blockchain and drones, it's just this cornucopia of technologies that are all innovating at an incredible pace. And they're affecting the physical world, not just creating digital artifacts in the digital space. So I think that's why I came to ABB, because when Uli interviewed me for the job, he said, Guido, are you a technology guy or a business guy? And I said, I think this is a trick question. So this is make or break. And so I said, yes. And so I think that's ultimately the answer, or one of the reasons I'm excited to be on this panel, is that digitalization, the intersection of business and technology, that's what this is all about.
Absolutely. Well, thanks a lot, Guido. It's great to have you here. So let's move into some of the themes of today, and really, as the number one, let's talk about advanced technologies in industries. And maybe you don't know, but we did some research ahead of this, and it says that Gartner predicts that 1/5 of enterprises will have positions devoted to monitoring and guiding machine learning by the year 2020, and that's already next year. So that's so the world is really moving here. And Michael, maybe start with you about being a leader here in the food and beverage industry, and I know that you are always adapting new technology very, very rapidly. So at Krones, what are some of the innovations and the new things that your customers are really looking for?
Thanks, Morten. There's one big driver, and it has 3 letters, TCO, total cost of ownership. I think everybody's familiar with that. And machines and lines are becoming faster and with more automation, and quicker changeovers between different products running on the lines. So overall complexity is increasing. And as the technology advances, the challenge is to keep those lines running efficiently day in, day out. And especially in a labor shortage and a skills gap scenario that a lot of us are in, that's not so easy. So our customers are asking for help on that front to help us better manage their assets. And ironically, we do that with more advanced technology, with a connected line, similar to what we're all talking about. And of course, Krones is on that track also. Our connected line keeps Krones by their side remotely for faster troubleshooting and for facilitating the move from condition-based maintenance or worst-case breakdown maintenance to predictive maintenance. So the connected line includes sensors, the cloud, remote access through VPN, smart glasses are integrated, and then dashboards. And the dashboards are on apps that have line efficiency, mean time between failure, mean time to repair, can also have sustainable metrics like waste generation, utility consumption, so we can enhance that also. And the more data is collected, the better our watchdog becomes with the thresholds between abnormal and normal operation. So it's a little bit like AI or machine learning, and I'm not the super expert on that, but we're getting into that, and the data gets better and better, and then the thresholds get better. So that's far beyond the old hotline or service phone support, the reactive, which we still use and is still important. But these connected line tools are more proactive. And that's how we're helping our customers to become even more efficient, which keeps their total cost of ownership, TCO, in check. Thanks.
No, well, thanks, Michael. So if you move on more to Richard on your side, I mean, you have seen the oil price with huge variations over the years. And how has BP as a company also then used innovation and technology to control costs and drive efficiency?
So it's clearly a big topic. So I'd like to approach it in the three buckets that I mentioned at the beginning. And it's interesting because each one, when I look into it, there's a considerable overlap with ABB activities. So as I do that, I'll highlight and acknowledge ABB for the work they do in this. So the first one is this dual challenge issue, supplying more power for the world to meet that demand, at the same time holding flat and hopefully reducing CO2 emissions. So within BP, the way we describe and drive that is something called the RIC framework, which is reduce, which is the R, reduce, which is reducing our own carbon intensity of our existing and future activities. So it's looking after our own space, the stuff we're responsible for. The I is for improve, which is improve the products that we make, and the C is to create new low carbon businesses. So I'll just pick some key examples. So the reduce area, reduce the carbon intensity of what we do. We've said that over the next 10 years that we intend to grow our production of hydrocarbons, in that gas and oil particularly in that period. We've made an external obligation that we're going to hold our own type 1 and 2 greenhouse gas emissions flat. We're doing that by reducing that, using all sorts of different technologies and projects to reduce the greenhouse gas of our existing operations. But what I'm involved in is the new projects, making sure we do that with as low a greenhouse gas footprint as we can do. And one key area, so last week we signed the agreements with all the partners to move into execute of a massive liquefied natural gas project in Mauritania and Senegal called Tortue. It's by far the biggest thing BP have done in West Africa for a long time. And a key part to that is LNG is, it's seen as gas as a key transition fuel of the future, but LNG itself is quite an inefficient method of transporting gas. About 10% of the energy in the LNG we burn basically to liquefy and create that LNG. So one of the things we can do to make that whole process more efficient is maximize the use of electrification of the devices we use, particularly the massive compressors we use in the refrigeration cycles to liquefy that. On this project in Mauritania and Senegal, which is peculiar because all of the infrastructure is going to be near shore. It's not onshore. It's not deep water offshore like the big floating LNG projects. It's a near shore project. So we're going to end up building a whole bunch of LNG liquefaction facilities on platforms. But also one of the key things we're looking at is running that through a combined cycle heat and power station. And ABB are paying, even right at the very early stages of this, ABB are playing a massive part in consulting on that and all the different options we have about power barges, onshore power generation. So the biggest single probably greenhouse gas abatement option we're looking at this year, and ABB are partnering fantastically with us in that. So that's improve, I don't know if people probably didn't see, but there was an announcement this morning in BP. We look to improve our products. And there was an announcement this morning, as I noticed, just on something called bioparaxylene. So we're partnering we're one of the biggest producers of something called paraxylene, which is a precursor of polyester and this stuff, PET, polyethylene terephthalate. We've partnered announcement today with Johnson Matthey and others to develop you've heard of biofuels and biodiesel, and this is a substance called bioparaxylene. So it's taking renewable feedstocks and converting that into paraxylene. Another interesting one is Castrol, our large downstream lubricants arm, are very focused on improving the overall energy efficiency of engines through the use of lubricants. So if you can reduce the viscosity of a lubrication oil but retain its protective properties of the engine, you can make a material difference to the efficiency of that engine. So, and if you look forward again between now and 2040, BP, and I think many others, see there is more potential to reduce the greenhouse gas emissions from the transportation sector from improving the efficiency of our existing fleets of cars and trucks than there is in electrification. Electrification is going to happen, that's clear, and there's a range of projections about the speed of that's going to happen, that's great. But there's a whole load to go for in the efficiency of the existing conventional combustion engine. And finally on this, there's the create new businesses. Again, ABB heavily involved in this. So there's wind, we have wind business, we have a solar business. And more we're getting involved in something called carbon storage and sequestration. So we're making carbon-free energy. So ABB again is involved with us in a carbon capture pilot plant in Imperial College in London. And we ourselves, BP, are running a key, in fact it's the world's biggest and only full-scale gas-fired power generation plants with full-blown carbon sequestration capability. So that's, I'll stop there on the greenhouse, on the sort of dual challenge side, but it's just remarkable when I look about the activities we're involved in, the overlap we have with ABB.
Yeah. Well, thanks, Richard, a great example. So, not just on the cost, but also on the efficiency side of what we can do. And maybe Peter, maybe you can give even more examples, because where we as ABB and you in industrial automation are really, when you talk about digital oil field, about autonomous operations, how can we really make a difference there?
Yeah, I think I'd go back to distinguishing the two stages in which we make contributions. The one is, again, the capital investment, large CapEx project phase, where really in the last few years was technologies like cloud-based engineering, which allows us to really bring together people who are close to the customer and the specific application, people who have a domain knowledge in other parts of the world, people who have built the physical and digital building blocks. To bring all that together in cloud-based solutions today is really something that helps us on the cost schedule and risk side. But then, in addition, the capability that we've introduced with digital marshalling of the systems allows us basically to not build things in sequence and first build the hardware and then the software applications that run on it, leading to something we've often discussed here in Houston, that basically automation is always last, but suddenly we can actually accelerate, schedule, and de-risk and decouple these two and really only bring them together at the end. So I think that's a big technology contribution during the capital investment phase, whereas when it comes to the operations phase, phase, we're really on a journey together with our customers at slightly different paces in the different industries that we serve, where it's all about moving from originally isolated automation, which is basically just there to run the process and keep the lights on, so to say, through definitely almost everywhere connected operations, increasingly collaborative, towards ultimately more autonomous operations. And if I give you an example for autonomous operations, just second half of last year, we had a project in the North Sea, an offshore upstream project, which was basically enabling the bringing up of new wells with 98% less manual intervention. So is this totally autonomous? No, there's still human decision making involved, but instead of a lot of manual interventions, which from a safety point of view, which from a quality of the operations, from a productivity point of view, is really an issue that translates into time and lost production, that translates into mistakes people can make. Going to 98% less manual intervention in bringing up these wells is really a huge step in the direction of more autonomous operations. So we have countless examples in the different industries of this nature, but that's why I'm so excited about digitalization basically as the next thing that naturally comes as an extension of our automation history that we all have together, and that adds new levels of customer value.
Right. Thanks, Peter. Richard, you have a comment?
Yeah, I just want to pick up on what Peter's point and really echo and really reinforce that, the first point he made. So he was referring to the ABB version of Select IO. So I've been in the business of 30 years, all of it in major projects, initially petrochemicals, then oil and gas facility. And time again, people talk about transformational technology changes in the automation industry. The whole Select IO that others are available, so Charms and Leap for the other major vendors, really is a massive transformation in how we do ICSS, integrated control systems across facilities. So the ability to massive, the fact that we've now put the basically intelligent configurable input-output cabinets in the field, massive reduction in field cabling. The ability to, we've separated the hardware design from the software design. We can do all the factory acceptance testing virtually. And the point that Peter made is very true. It takes the whole ICSS configuration and testing off the critical part of major projects, which for pretty much all my career they've been tail end Charlie. They'd be the person that got all the pressure, and late changes became a really big issue. Fantastic cooperating. Hats off to Exxon. Who are the people that really drove the need for this from a customer perspective, but I think fantastic from the supplier's perspective, ABB included, to deal with this, a customer problem, very collaboratively to create what really is a transformational product with your Select IO.
Thanks, Richard. And Guido, over to you. I mean, we are talking so much about this digital transformation, and the world is going digital, and I think a lot of people maybe are even a bit lost at times. Where do we invest? Where do we go here? So, what would be your advice on that
Sure.
topic?
So, great question. Where do you begin, right? There's digital technology everywhere, and one of my first questions that I always get asked is, what is digital? And I say, well, don't you have a phone? Don't you have a computer? But I think people really want to ask the question, what is digital for me? And one thing that I think helps is to start looking between, Richard was articulating a number of pain points, and there's a simple saying, it's easier to sell aspirin than vitamins. So if you can solve a pain point, that of course is a good place to start. So now the question is, what pain point? Where do you start? And one of the helpful things, and I'll put in a shameless plug for my talk tomorrow morning, so if you come to my talk, you'll see a nice way of looking at this, which is a customer value chain. So how does a customer learn that you have an offering, choose among all the offerings you have? How do they buy or get it? How do they design and deploy it? How do they operate it? How do they optimize it? So that was also what Richard was referring to, some of that ongoing optimization, building on what Peter said about autonomous as well. So that's the customer value chain. And then on the y-axis, if you think about this, you have individual devices, systems, a plant, the enterprise, and the extended ecosystem of a collection of other partners. with which you interact. So I think one first thing to think about is this creates almost like this two-dimensional matrix, and you can now plot on this matrix where do you have the biggest pain? Where do you have typical issues around uptime, speed, yield, safety, energy, security? Those are the key drivers. And on this map, on this table, you can start to plot where you should be looking for your digital initiatives. Because obviously you want to try and address the biggest pain points and also the areas where you can have the biggest impact. So I think that's a handy way to start thinking about that. And then of course you have to discover whether or not even digital technologies exist that can solve those problems, but that's a different story. But I think where to start, that helps with that. When to start, to your question, Morten, I think the answer is clearly yesterday, but if you didn't start yesterday, then do so today, because today is a better day than tomorrow. And the reason I say that is because these digital technologies are moving at an incredible pace. And one of the reasons that we have chosen to partner with some excellent partners like Microsoft and HPE and IBM and Dassault Systems is that no one of us is as smart as all of us. And I think there's also a very nice African proverb that says, if you want to go fast, go alone, but if you want to go far, go together. So we think that the time is now, and look for partners to help get you there.
Thank you for an excellent summing up of the whole topic, really, of digital industries also for the future. If we look at another statistics, it's an entry to our next point. It's that in US, retirements and growth mean 3.5 million new manufacturing jobs will be needed to be filled by 2025. And at the present trend holds, then we will have a gap of 2 million jobs at 2025. That means we need more skilled workers for our industries. And Michael, maybe I can hand it over to you, and in your perspective, how do we fill that gaps? And who do you think is responsible versus the industries, the government, and or how can we be able to fill that gap of about 2 million jobs?
Yeah, it's a great question, Morten, and a great topic. Thanks a lot for that. So you mentioned the industry, the education, and government. And those three have to work in partnership. And I think in many cases they do. But of course the partnerships can be strengthened. And there's a fourth role there too, and that's the public, primarily the parents that play a role. And that's a lot of us and everybody else out there. And I'll get back to that later. So a primary opportunity right now, like you said, is the quantity of the graduates coming out of our technical education system. And that's the STEM roles or STEM program, right? Science, technology, engineering, and math. And industry is sometimes bottlenecked by not finding enough of that technical talent for our businesses and factories. I'm pretty sure that's old news for a lot of you. So I sit on a technical college board, a so-called two-year college. That's what we call them in the US. And the bottleneck starts there, unfortunately, on the student intake side. We wish we had more students coming into the technical college straight out of high school. It's something like only 10% of high schoolers go directly into this technical college. In 2017, it was 9%. The vast majority go to the four-year college or university system. And the rest of the technical college student intake are what I call the Plan B'ers. But it seems the public, that's us, and it includes me too, generally want their kids to go through a four-year university program. Somehow we feel we can achieve more success that way. But manufacturing has changed a lot since the Industrial Revolution. It's clean, it's safe, it's well paid, it's highly skilled, it has career paths, and it's challenging. So it's very different than, I don't know, half a century ago. But as a result of this university priority scenario, our technical colleges are sometimes the Plan B after a Plan A of the four-year college program that didn't work out. And that's a problem. I have a solution idea if I have a minute.
Yes, please.
So we all try to live in the solution, right? We don't want to live in the problem. So here's an idea. And I'll come back to the question that you had, Morten, of the role of government, education, industry, and I added the public or the parents. So the idea is this: to devise a holistic 10-year program with a catchy name or brand, something that has excitement to parents and students. It's nationwide consistent, and it could go something like this. Phase 1 is after high school, and it has 2 years of a technical college, a 2-year program, and then a 3-year apprenticeship. That's the 2-year college diploma or associate's degree. Phase 2 is another 5 years and has 2 years in a university and another 3-year apprenticeship. And the university, the 4-year program, recognizes the 2 years from the technical college. So the student, in the end, ends up with a 4-year degree. So it solves the backwards Plan A and Plan B problem. And I'm sure a bunch of Phase 1 graduates probably wouldn't go on to Phase 2 because they already have challenging roles. They have high or well compensation, and they have career path opportunities. So that's the vision, that's the program that I think something parents could live with to get over this perception of 2-year versus 4-year. I know I could live with that. So he who has the pain should campaign, so that's what I'm doing back in Wisconsin. And this 10-year program solves 3 pain points I have, because I wear 3 hats. One as a business leader, not having enough talent coming in. One as a board member of the Waukesha County Technical College, not having enough high schoolers come directly in. And the third one as a parent of 2 boys in the 4-year program, and that's where they started. And I'm not sure that's perfect for both of them. I'm going through some of that right now. So I'm interested to hear any feedback from anybody later on that idea. Okay, thanks.
Great proposal. Thank you. And Guido, I mean, how does autonomous technology amplify human potential as opposed to replacing it?
Yeah, so earlier Peter made the point about autonomy as being sort of the next logical step, but it's more of a continuum. It's not zero autonomy, full autonomy with no people required. In fact, there's a term that I would like to promote. I didn't come up with it. I read about it in The Economist, so I'll give them credit. But it's the concept of the human on the loop versus the human in the loop. So the human in the loop is you are part of the integral process. On the loop would be like a ship captain helping with an autonomous vessel. So in Peter's area, his team has enabled that in Helsinki, for example. But you can imagine in mining, in autonomous cars and buses and trucks, you could have people always available for when the AI can't make the right judgment. Now, some people are saying, oh my God, the robots are coming. And I would actually say to that, yes, and just in time, because we actually have need of tremendous numbers of people, because if we think about the challenges ahead of us, we have an aging of the population. I'm sure Richard can talk about that in specifically oil and gas, where the average age here in Houston is close to 55, and half the knowledge workers are going to retire in the next 10 years. We also have a tremendous effort underway to go from fossil fuels towards more renewables. Already today, more people work in terms of the United States, where renewable energy is 20% of the mix right now. More people work in that sector than in oil, coal, and gas combined. So as we look forward, we need a tremendous number of people, and I'm not sure that we can do that just by throwing bodies at the problem. So we need to, of course, educate them, but we also need to have tremendous amounts of automation. If we then go further and say energy transportation, so while we look at autonomous cars and trucks, not a lot of people know that, in fact, we need more truck drivers today. We actually have a shortage of 40,000 truck drivers in this country, so if we could find them, it'd be great. But it's also a career that for some people is very challenging to combine with family and strike a good work-life balance. And then if we continue on into things like food, within the next 30 years, we're going to have 2/3 of humanity living in cities. We're going to have to feed another between maybe 2 to 3 billion more people. We don't have enough arable land to apply the current method of agriculture to feed those next 2 to 3 billion people, we need to go towards urban farming, growing food in 3 dimensions as opposed to 2. We need hydroponic systems, automated systems to bring down the cost of doing that. And then lastly, water. So we don't realize this, but there's many parts of the world that are being affected by climate change, and access to clean drinking water, pumping it from longer distances away, for example. In California, where I live, moving water is 20% of all the energy that we use. So we need to rejigger the way that we get water to people. That means things like desalination plants. So all of these sectors, all of those major shifts to transition to a new operating model for the world of tomorrow are going to require a tremendous amount of jobs, and we have to do that with automation, not instead of automation. It's also true that the automation will unlikely replace all of these jobs, simply because, as we've seen in every technology revolution to date, we always create more jobs. And my favorite example of that is, I don't know if anyone in this room could have predicted 25 years ago that today there are hundreds of thousands of people around the world who have a job called search engine optimizer. I mean, who the heck knew, right? This is a completely new job because we have search engines, we have the internet, and this is an integral part of how we do marketing today. So I think we need the automation. We need to automate the jobs that are the 3Ds, dirty, difficult, and dangerous. And then we need those automation components to help us as we transition our economy towards an increasingly diverse mix of fuel sources, the electrification of transportation, growing more food, and providing clean water for all. So we have some tremendous challenges, and we need every person and robot we can find.
Thanks. Thanks, Guido. And Richard, how do you see from a BP perspective that you're also, now you're going with digital oil field and autonomous operation, what's the skill set gaps that you see from your point of view?
Yeah, so in terms of resourcing for the digital future, so clearly there's, with digitalization, there's a huge, clearly, demand suddenly for data analysts, and clearly we're in the market for those as everybody else is. What we have found, though, is, BP is an engineering company. We recruit huge numbers of engineers from colleges all over the world. And they are numerate, ingenious, imaginative, and ambitious individuals, largely. And when faced with the current generation, the young generation, when they're faced with a real frontline business problem, they are incredibly adaptable, a subset of them, at taking the tools. So the machine learning element of Azure is a good example. The stuff in Power BI beyond just the donut charts, so the real power stuff behind Power BI. That they're almost by themselves discovering the application of these tools, to some extent, as earlier in my career, the use of macros within Excel. The current generation are using these more sophisticated tools, applying them to frontline problems and having remarkable success. And that subgroup of people who show a passion and an ingenuity to use the tools to solve front-end problems, we're very much trying to encourage that in-house growth of those people, giving them credit and giving them space to grow that. So there's an element of in-house retraining to some extent, but allowing people to understand the domain knowledge and use the tools efficiently. And clearly, we're also in the recruitment game of recruiting and training, particularly data scientists. So very recently we've formed a new digital function. So before it was all just people, and the money that we spent in BP and upstream was distributed across all the regions and the functions, and we've centralized that now into a single digital function, such that we can focus the resources being competent people in the digital space, and the money, the capital we spend on these projects, focus, prioritize, and speed up the way that we deploy new digital solutions.
Mm-hmm. Thanks. Great. I mean, some really good examples from BP and from Krones, what they are doing. But Peter, maybe what is ABB doing in this perspective?
Well, first of all, I have to say it's a pity I don't vote here in the US, because I think Michael's proposal I found very compelling. Looks really like an approach I would be voting for if I had a chance. At ABB, I think there's a number of things we're doing. If I first still start on the societal side, I think we got two big untapped potentials that I think all of us we can contribute towards tapping. And the first thing is actually getting people even interested in doing what we're doing. Making engineering cool again, I think, is absolutely something where you find traces here in the States of, for instance, the maker movement, where people actually get excited by solving interesting technology problems, by actually also repairing difficult things, by using technologies like 3D printing to make things that weren't feasible before. So I think making cool what we're doing is part of attracting people. So I think we have to get better at that. I think next ingredient there, if we look self-critically at ourselves, we have a fairly strong gender bias in terms of there's half of the population, the female half, heavily underrepresented in the engineering population. So this is a potential that not only here in the US, I think we have very similar challenges in Europe, less so maybe in some other parts of the world, but addressing this part of the population. And then really, I think at ABB we've often discussed and we've also implemented programs to deal with that. Long gone are the days when you initially studied something and you learned the equations that you need for your technical discipline to say, how do you dimension a motor? Maxwell's laws and some of the more immediately applicable rules of electrical engineering, you learn them. And then basically you use them for the rest of your career. I think our forebears had that possibility. Today, we still need to understand the fundamentals of the laws of physics, the fundamentals of a domain, but there's clearly a need for accelerated education and a more permanently updated education. So exposing people to new challenges by actually also exposing people within a company to new job profiles, and then adding new dimensions like digitalization to it by bringing a combination of people who really are experts in a field that has been one of our traditional strengths, and combining that, as we're doing with Guido and his team, with people who are expert at something that is new, like digitalization, bringing that together. I'm convinced, one, there's a lot of learning that's happening at that interface, but two, also that innovation historically, there's lots of cases to prove that innovation often happens at discipline interfaces. So I think that is something that will serve our people well, but it also is something that will come up with totally new solutions and has a lot of potential.
Thank you. Thanks, Peter. And just as a note here, you see also on the screen, ask a question, and you can use your phones and the app for the ACW app, and you can there also just select the schedule for this event, and you can type a question, and I will address that also in the end. So, if we take our third and last topic of the day, we talk about the contrast of discrete automation and the process automation. And there we can also set an interesting point is that the amount of human labor directly required for survival of humanity, that will keep shrinking thanks to automation. So there is hope. And Michael, when we look at the trends in discrete automation, there you have the Amazonification of consumers. How do you, and how is customization affecting your business?
Another good question, Morten, thank you. Can we first maybe clarify the discrete versus the process? I Googled it, and what I found is process automation is continuous, like a refinery perhaps. You can't count things coming off the line, and discrete is like the food and beverage where you can count things coming off the line. Is that correct?
That's a good description.
Thanks for that. So Amazonification, that's a hard word, and it has many implications. Of course, e-commerce, wanting something that perfectly meets the need or solves the problem with almost infinite choices, and then getting it fast right to your doorstep. So it's that instant gratification, which we didn't grow up with, but we like it, and our kids think it's the standard, and probably is becoming the standard. So Amazonification also includes vertical integration, private brands or in-house brands like Amazon Basics, right? The elimination of the middleman in many cases, and economies of scale. So it's a tough nut to crack, that's for sure. So now back to food and beverage. What that means is that food and beverage has to be as nimble, as cost effective, and as flexible as ever, including having strong brands. And lots of choices means having lots of different flavors, lots of different variations of a brand available in different size packages and different size cases. So an example could be that there's a 12 ounce, a 16 ounce, and a 20 ounce package with many flavor variations, and then those things go into cases that are sometimes 6 packs, 12 packs, or 24 packs. So you get the idea that there's quite a bit of added complexity in the supply chain, the factories, and the warehouse. The number of SKUs have increased substantially. So we have increasing product mix complexity and downward price pressure, primarily due to Amazonification. And those aren't typically complementary. So it's not easy. There are positive drivers. Differentiation is one of them, and premium branding is another. Innovation is another one. The industry is innovating on the product side, so the product we consume, but also the packaging to make that more unique. And then lightweighting is another thing we all see, right? These things are getting lighter and lighter, and that's a cost savings plus an environmentally sustainable directive. And then simplification is another one, right? We're talking about adding complexity, but the industry tries to simplify wherever it can. So we already talked about some of the solutions: automation, remote support, workforce development to ease those customization effects. But the other variable is that economies of scale. A major producer, they can have a line that runs only 12 ounce, another one that runs only 16 ounce, another one that runs 20 ounce. So they're able to be more efficient, and of course that has to be balanced with the freight, how close you are to market. That's another driver or a variable that has to be figured out. So that's the reality, Morten. That's what the food and beverage industry is facing every day. And I hope that answers part of your question. I guess the answer is it's complex and it's not getting easier, right?
But it's interesting, everybody wants their own label on one bottle.
Yeah.
So that's the future of your industry.
Yeah. And a simplification could be direct printing, right? Instead of putting a label on the bottle and having to order, design labels, you print the bottle, right? And that thing is coming. It's not that fast yet, but it'll come, and that's an example of simplification. Another one is cans versus bottles. A glass bottle especially, right? A can is lighter, you don't have to label it, so that's another simplification. And you see that in the beer industry. There's a lot more cans versus the glass bottles.
Thanks. No, it's very interesting, but I guess for Richard, you're going on more in the opposite direction. You don't want to have everything customized, you would rather like it standardized. Is that correct?
Yeah, so the term standardization is often used in the oil and gas industry, and throughout my 30 years in the industry, it's been incredibly elusive. For those outside the oil and gas industry, it's hard to believe how incredibly inefficient and bespoke the method by which we specify and procure equipment from the likes of ABB is. And one silver lining of the recent oil price collapse, 14 till 16, 17, was that finally the executives of most of the leading 12 oil and gas producers in the world got together and said that this is non-sustainable. So the fundamental issue is when we specify something like a drive, a motor for a pump, or a pump, let's say, there's a base industry standard, API 610 in the case of a pump. And each company, BP, Shell, Exxon, Mobil, you name it, Saudi Aramco, Petronas, all have their own very detailed, very bespoke supplementary specification that they put on top of API 610. They give that to often to a reimbursable engineering EPC contractor, and there's a whole cottage industry of them creating a procurement specification for that pump. that's often discrete and specific to that project and to that company and to that EPC contractor. So when someone like ABB is on the receiving end of that, they're receiving a often 500-page document. Every one of those pages is different and discrete from the previous order they received from the same company for the same product. So there's been various attempts to get to the nub of this, but there's a huge advance that's taking place. It's something called Joint Industry Project 33, where the top 12 operating companies, and the people I rattled off, Equinor's in there, ENI, Total, ConocoPhillips, and they said, right, let's get over ourselves. This customization, this company specification of something like a pump or a low voltage switchgear. Let's stop that and let's have a common oil and gas industry approach to how we buy that. This is the technical specification. It's the quality specification, the inspection and test plan. Believe it or not, each company at the moment asks a different inspection and test plan often for when they're buying, a pump from ABB. So let's have the same technical specification, same quality requirements, same document and data requirements from the company. So we've started that. It's got a huge. What's great about it is got executive support, so CEO support from the top of these 12 companies. It's being done under the umbrella of something called IOGP. We've just finished phase 2 of that at the end of last year, and we're kicking off phase 3, which is to address another 40 to 50 equipment class products. So the intent of this is to basically commoditize equipment that's supplied to the oil and gas industry to get away from this ridiculous bespokeness we have at the moment.
All right.
Okay.
Great. So now you have.
Oh, sorry. Just another big up ABB. ABB have been involved from the beginning and have been incredibly cooperative and helpful in this initiative.
Thank you. Now, so customization, Guido, on one side, standardization on the other side. Where do you see the digital technologies? How will it develop, and how can we help there?
Yeah, I think this is a little bit like my technology versus business question. I think the answer is yes. I think we need to standardize and create that agility that Michael articulated so well. I think one of the things we see is that while right now a lot of the interest in digital is focused on things like condition monitoring, I just need to put a sensor on something and make sure that it's still operating. I think what both Michael and Richard are talking about is that there's a tremendous amount of cost. So Michael was talking about the cost or the lack of agility or the lack of flexibility, and that's sort of how I interpret some of the things you said. And then Richard was talking about the tremendous cost of complexity in the procurement side in the early stage of this. So if you fast forward, we could imagine how this might change. And in fact, one of the things that is interesting to think about is that even though Michael was clarifying the difference between process and discrete industries, arguably with the trends that we're seeing, those two distinctions could very quickly blur. And what I think is going to happen is increasingly the advent of smart machines, so that the biggest problem, I think, in a lot of the industrial infrastructure is not so much whether or not a piece of machinery is available. What we really have is a lack of flexibility and agility. So Michael was talking about something like the equivalent of getting down to lot size 1. How do you make something in very small batches with the same efficiency and scale that you can make things in very large batches? Reconfiguring an assembly line today is very difficult, takes time, it's costly, it's difficult. But one of the things that we hope to be able to do with our partner that we just announced last week at Dassault Systems is that as the leader in digital twin, you can design a layout, you can simulate the layout, and then hopefully reconfigure this layout. And that will happen increasingly quickly because not only the robots, which are already programmable today, but in the future 3D printing, CNC machines, so more of this assembly line or process plant is going to be made up of smart machines. They will reconfigure themselves very quickly to suit the task. That's going to give more agility, more availability, boost productivity overall. And then I think to Richard's problem about how do you simplify the diversity of technology that you do on the procurement side, there I'm actually very optimistic about something called generative design. So imagine today you're talking about a 500-page RFP. What if tomorrow your RFP is actually an executable spec, meaning you actually issue digital requirements, and then suppliers, people who want to bid for that, can actually submit their digital twins of the components they would supply, and you can test whether or not they actually fit for purpose, whether they're powerful enough, the right size, and conform to the right specifications. So I think that we're going to be able to have our cake and eat it too. We're going to be both highly standardized and very flexible to suit both requirements.
Very good. Thank you. Let's take a question from that we have been received also from the audience here. And I think this one, I think we should ask it to you, Richard, because it's about oil and gas. Because we're saying, I think it's been repeated quite many times in the session here, that the world is going electric, and also in the automotive sector. So how do you see the demand for oil in the next 20 years?
So there's a, well, I would say this because it's a BP document, but I believe it's well written and well intentioned, and it doesn't have an agenda. There's a brilliant document called the Energy Outlook that's produced every year by BP. It's just been produced. There's another McKinsey version of that, and I would thoroughly recommend anyone that's interested in the oil and gas industry, or the energy industry in general, to use those two documents as a base understanding of the trends of power. So if you take the data out of that, it largely sees oil, so liquid fuel, including NGLs, being flat between now and 2040. Yes, certainly in the electricity generation area, renewables is having a remarkable effect. And 50% of the energy growth between now and 2040 is going to be renewables. The vast bulk of that goes into electricity generation. On transportation and electric vehicles, it's the view that, people might say, well, BP would say this, but various other people agree. The impact of electrification is there, but it's surprisingly slim between now and 2040. It will increase, and BP is massively into. So we have bought into and now partnering with a company called ChargeMaster, which is the largest electrical vehicle charging thing in America. In the UK. Again, we partnered with ABB for some trial electric vehicle stations in Shanghai and China. So clearly, it's the way of the future. I mean, it's a key part of our future business model. But the speed at which it impacts liquid hydrocarbon consumption is surprisingly small. So things like the use of joint vehicles, the increase in vehicle efficiency is seen as a bigger. It is likely to be a bigger impact between now and 2040 than the uptake in electrical vehicles. Even the most optimistic view on the increase in electrical vehicles. So it's going to happen, but certainly out until 2040, the predictions are the oil demand is roughly flat. Right. Gas increases, oil flat.
So we keep on to our BP shares for some time. That's what you say.
Yes, please.
Right, I have another one, and I think, Guido, maybe I'll hand over to you for this one. It says, digitalization seems to be a natural evolution for large companies. Can you provide some suggestions for small to mid-sized companies, especially those that do not have a CTO or the owner also wear the hat of a CTO?
Yes. So it turns out, I saw a recent survey that was done by, in fact, Ray Wang, who's here from Constellation Research. It shows that in large companies, much of the digitalization is done by chief digital officers, but in smaller companies, it's quite often the CIO. And I think that makes a lot of sense. I think, obviously, a capable and good CIO can also function as a chief digital officer in transformation. And I think that the key thing is to try and identify the kind of niches or the markets or the segments that you can bite off. Digitalization is such a big thing. You can digitalize your internal supply chain, your HR, your finance, your operations, your products, your services. And of course, with corresponding scale, you have to decide that you probably don't want to eat the elephant in one bite. You want to try and consume things in reasonable size. So picking your targets wisely, I think a good, incredible CIO can and probably should be leading your digital transformations.
Thanks. Peter, we have also a question here around launching of programs to digitalize and improve automation at a manufacturer requires time and money to be invested. Given the need for resource justification, what's the methodology to determine the value that can be extracted by these technologies?
Well, that's a tough one, but it's one that we actually often face when we introduce more radically new methods and technologies, to then say, okay, what do I need to believe to make this a viable investment case? And look, from my perspective, First of all, there needs to be the potential. When we talked about standardization, when we talked about customization, you need to actually identify what is the potential that I'm addressing. Was this in the case of, say, the substation standardization that also Richard talked about, and yesterday Kenny Warren from ExxonMobil talked about? Clearly, the potential was that we keep each other busy by exchanging specifications and making our life complex without actually coming with a more reliable, safer, or cost-efficient solution. So cutting that out was clearly, for all involved, the case for standardization. And we started with the potential, but basically then on the basis of the potential, we found the solution, and we invested the work on both sides to basically go for that potential. And similar, if you look on the customization side, what the potential can be. One of the things that struck me 6-7 years ago when I was leading our German operations in ABB was we were discussing Industry 4.0 and the potentials that it could bring and how would it change production. And we were running all sorts of pilot projects, as you would imagine. But then I actually looked, are there any real customer orders that are not pilot projects, and actually came, surprisingly, to the example of the shoe industry, who basically said, we want to make it possible for our customers that basically you can, on the web, design your own shoe. And basically, we have equipment, dedicated machines, with our robots that went into those solutions that actually produce the shoe you want. Now you say, how is that relevant as a potential? Well, if you think through the supply chains that are involved, in the one case, basically, you make a bunch of shoes independent of actually knowing what your market is, and you make them in some low-cost labor place, you put them in containers, that's inventory tied up in transit. You're never going to hit exactly the demand that you have, so at the end of the season you have to either dump them price-wise, or you have to literally scrap them. So there's a lot of capital tied up, and there's a lot of waste in the process, and that is your potential. So on these two examples, and I think on all the business cases we have, it's basically, what is my business case? If I take my own manufacturing, business cases of the type we have in industrial automation, where we also produce certain products. A business case can be, I have a warehouse full of parts, say in our turbocharger business, where we really support the different chargers that we have delivered over time, and really a world-class service offering. But actually, it's a big warehouse, and as technology advances, we may have better ingredients, so we may have to scrap and write off some of the components. So what if I went to actually make some of these pieces just in time with technologies like additive manufacturing? What's the business case related to the potential of not having all that capital cost and obsolescence risk sitting there? So, and then of course you have to believe in your capability to actually also execute. So it's these two ingredients, potential and ability to execute, that at the end of the day, typically it's not rocket science in terms of then doing a case. You may not get it right with radical new technologies in terms of saying, is this a 2.7 year payback versus a 2.5 year payback? But it's usually pretty obviously either too long a shot or one that you should be doing. So we don't actually end up with so many cases on the borderline. It may not be an exact science, but it's actually fun to drive these decisions forward and change the way we work and produce.
Yeah. Thanks. Michael, your 10-year plan was got also interest from the audience, so very much appreciated. And so we got a question as well as a follow-up.
Okay.
Yeah, your 10-year plan is very intriguing. What your views if we initially incorporate the technical training at high school level as opposed to after high school?
Yeah, good question. And we do that already. We have a dual enrollment program in Wisconsin. I assume it's also in some other states, where high school students work ahead and they go to a technical college and take courses already there while they're in grade 11 or 12. So we have that program, and this could build on top of that. And my passion for this is another statistic I'll tell you, Morten, that out of 20 people that are required in the workforce, And it goes something like this. One needs to be a PhD or a doctor. Maybe one or two have a master's degree, and then there's a handful with a 4-year degree. But the vast majority of people that we need in the workforce, a 2-year technical college degree suffices. And we have this debt problem too, right? The 10-year program could be a shared cost thing to have industry have more skin in the game. It could be a 50-50 thing. But that's where I'm coming from, and building on that dual enrollment thing, which already is going on.
Very good. No, and I see also it's a lot of good initiatives from some of our partners that is also running great programs or internships, and how we can also bring people in early and giving them opportunities. I've heard that over the last days and also visiting some of these companies. I think it's a lot of good initiatives going out around in the country, and as most of the feedback what I get from many of these programs, it's good for business, and it's good of course for society as a whole. So this is really also building internal brand reputation, and I think also in the local community. So I think good opportunities here also to do more in and it's needed for the future. With that, I think we will close the day. I would like really to thank you also. I mean, today we really looked at the future of industry, how it's changing both the workplace but also our workforce for the future. Some great opportunities, but also some big challenges that we have to address together, really between industry, that means ourselves, the government, and also using the education institutions, so we can ensure automation makes human work more human. So with that, I would like also especially to thank Michael and Richard for joining us here on stage, and also Guido and Peter from ABB from our side. So thanks a lot. And then I would like to, and yeah, before that, just a second, we have, before I'll hand out also, and as I say, as our appreciation, just also for tonight, please enjoy the rest of the day. We have a lot of interesting meetings and trainings going on. We'll see a lot of interesting things down on the floor. So, and then at 6:30 tonight, we'll have, I hope everybody have the chance to join us as well for a great evening together. But with that, I'd also like, on behalf from ABB, Michael, thank you very much for joining.
Thank you very much.
Thank you. And Richard.
Cheers.
And thanks everybody.
Thank you.
Thank you.
Thank you.